In this lecture, we'll learn how to find the nature of the station point. Now, you already know from the previous lecture that how do you find the station point. Now, station point can either be a maximum station point or a minimum station point. Now, how do you determine that whether it's a maximum or a minimum station point? We'll learn about that in this chapter. Let's say I have a curve, this. F of x equals to, this is f of x, this is x. Let's say f of x equals to negative 4x square plus 4x plus 4. So now, first of all, in determining the nature of the station point, you have to find the station point itself. So what we'll do is we'll take its first derivative, which is negative 8x plus 4. From this, we'll get the station point equals to x equals to 2, and f of 2 will be negative 4 into 2 squared plus 4 into 2 plus 2. This will give us negative 16 plus 8 plus 2, negative 8. This will give us negative 8 plus 2, negative 6. Alright, so this is negative 6. So station point is at 2 and negative 6. It must have been here somewhere, right? So this just curve is just for reference. It is not the actual curve of this function. Alright, so this is the station point. Now to find the nature of the station point, what you have to do is you have to take the double derivative of the function, right? F of x, you have to take the double derivative of this, right? So we already know the single derivative is negative 4x, negative 8x. It was negative 8x plus 4. Our double derivative will be negative 8, right? Or you can write this as in terms of d by dx in terms of y and x equals to negative 8x plus 4, and double derivative is d squared y, because we are applying d by dx the function, over dx square equals to negative 8, right? So this answer is less than 0. When this is less than 0, the station point which you have is a maximum station point. So this is a maximum stationary point. As you can see that this is the maximum station point. This is the maximum point on the curve, right? The maximum point in the curve is 2, negative 6, which also is the station point. Now, station point or maximum or minimum, but a point must be station point for it to be a maximum point in the curve or the lowest or the minimum point in the curve, right? Now here, when we took the double derivative of this, the x term was eliminated from the expression. The x variable was eliminated from the expression. Let's say if x wasn't eliminated, what would we would have done then? So let's do an example. Let's say y equals to x cube plus 4x square plus 4x. Alright, so and they have asked us to find the station point of this equation and also to find the nature of the station point of this equation, right? So first of all, we'll take the single derivative of this, which will be d by dx of y, 3x squared plus 4x plus 4. We'll equate the single derivative equal to 0 because at the station point the gradient is 0. From this we'll get this is 3x squared plus 8x. This is 8x plus 4. So from this we'll get, let me calculate, x equal to negative 2 by 3, or x equal to, let's say this is x1, x2 equals to negative 2, right? And our station points will be, this is our f of x, so f of negative 2 by 3 and f of negative 2, right? So station points are negative 2 by 3 and f of negative 2 by 3, and f of negative 2 by 3 is the value you get when you put negative 2 by 3 in the place of x in this equation, and the other stationary point is negative 2 and f of negative 2. Now we don't know which one of these two is the maximum or the minimum, right? For that we have to take the double derivative of the function. Our function was y equals to x cube plus 4x square plus 4x, right? Single derivative gave us d by dx of y gave us 3x squared plus 8x plus 4. Double derivative will give us, if I apply d by dx on the d by dx of y again, 6x plus 8, right? So now this is double derivative is d square y over dx squared equals to 6x plus 8. Now to find the nature of this station point, I'll put the x coordinate of this station point in this function, right? This function is this 5f double complement of x equals to 6x plus 8, right? I'll put the x coordinate of this station point to this function. I'll get that was negative 2 by 3, negative 2 by 3, 6 times negative 2 by 3 plus 8. So from this we'll get positive 4. As positive 4 is greater than 0, this stationary point right here is the minimum point of the curve. Alright, and let's check the nature of this stationary point when x is negative 2. So I'll put x negative 2 right here. This is also this will give us negative 12 plus 8 negative 4. So this stationary point with the x coordinate is a maximum point because it is less than 0. This one is a max point on the curve. So let me write this down all for you. To find the nature of the stationary point, finding nature of stationary point, what you do is, first of all, put dy by dx equal to 0, find stationary point, then f complement of x equal to, if this is stationary point is x comma y, right? If this answer is greater than 0 when the x coordinate stationary point is put in the double derivative, then you have minimum stationary point. If it is less than 0, then you have a maximum stationary point. Or let's say in a special case you don't have any x variable in the double derivative, such as in this case you don't have any x variable in the double derivative. So whatever the double derivative gives you will determine the nature of the stationary point. In this, the double derivative was less than 0, and the stationary point was a maximum point, which can be proven by this graph. If the double derivative would have been greater than 0 right here, the stationary point which we have already calculated would have been the minimum point of the graph, minimum stationary point of the graph. Alright, so that's how you calculate the stationary point of a graph and determine the nature.